In this lecture, we'll discuss the working or operation and construction of SR non-gated NAND latch. We can simply called NAND latch also. Okay, so this is the logic diagram. Here we need two NAND gates, two input NAND gates. One of the input of this NAND gate is connected to S, and one of the input of this NAND gate below NAND gate connected to R. And this NAND gate output is Q, this NAND gate output is Q bar. This Q we are taking and connecting here, and this Q bar we are connecting here. So this is called cross coupled connection. So this is the construction of a NAND latch. Now we'll see the working. So generally this is the truth table. How we got this truth table I will explain very detailed. Okay, first we'll see the truth table format. So there are two inputs, so four combinations will come 0 0 0 1 1 0 1, and there are two outputs. I listed two outputs. So for 0 0 I am getting 1 1, and for 0 1 I am getting 1 0. For 1 0 I am getting 0 1. For 1 1 I am getting 0 1 only. Okay. So here this is the state or state name or condition name. So whenever both are 1 1 output, both are 1 1 are same, that is we consider as invalid condition, because both outputs should be complementary. Okay, that is the condition. So it is violated that condition. That's why it is invalid or not used condition. This is not useful as memory, because ultimately this latch is for storage. Okay. So this condition we treat as set. Set means whenever, so these three conditions are called valid conditions because both are complementary. See here. Okay. These three satisfied the condition of complementary. So these three we consider as valid conditions and memory conditions. Okay. So in this condition I got 1 0. Whenever we got 1 Q, that we consider as 1 is stored. 1 means set. Okay. But why we are not considering Q bar? This Q bar is just a complemented version of this one. This is same as this one, just it is in the complemented version. Both are same. That's why we are considering only one. Okay. So here in the third condition 0 1. Now 0 stored. So this is we called reset. 0 means reset. Okay. Then next again 0 1. So previously 0 1, now also 0 1. It is maintaining as previous. So whenever it is maintained as previous, then we called hold or latch or no change. Okay, right. But out of four combinations, I told this we don't use. These three are memory. But out of these three, these two are same. That's why you can neglect one. You can consider this one. So finally, we will consider this set condition and reset condition. In set condition, 1 is storing, reset condition, 0 is storing. Okay. So now we'll see how we are getting these Q bar values, invalid, set or reset to hold, everything we'll see step by step. Okay. Now the first condition, S equal to 0, R equal to 0. See here, I listed that condition, S equal to 0, R equal to 0 is the condition 1. Okay. So here I am applying S0, R0. It means this NAND gate, one of the input is 0, but we don't know other input. Here also, one of the input is 0, but here we don't know other input. Even we don't know other input here and here, based on the single input, we can predict the output here. Okay. By using NAND gate definition. What is the NAND gate definition? If any one input is 0, then output become 1. Here also any input 0, output become 1. So here output become 1. Q also become 1, Q bar also become 1. So this is happening in the first condition. Okay. And I told both outputs should be complementary. That is the rule. So it's not following that rule. That's why we call it as invalid or not used condition. Okay. Now we'll see second condition. See what is the second condition? 0, 1. See here, 1, 1 we got for the first condition. Okay. Now 0, 1 second condition we'll see. 0, S0 or 1 is the second condition. But in second condition, I will explain with the different cases. This is the case 1. Okay. But in all cases, this input will be S0 or 1 only. Okay. So here S equal to 0 or equal to 1. And what about these values? I feed back the previous condition values. So previous condition values 1, 1 now output values. So now those 1, 1 came here. Okay. Now what is the output of this gate? If any one input is 0, output 1. Here both are 1s, output is 0. Okay. Right. But we should not write this output immediately in the truth table. Okay. We have to check whether this output is stable output or not. Okay. Stable output means I will keep this 0, 1 input as it is. Then I will feed back these values. When I feed back these values also, again I am getting 1, 0. Then that is the stable output. That stable output we have to write in the truth table as final output. Okay. So that's why in the next case, this is the second condition only, but the second case will feed back this case 1 values. Then we'll check whether it is stable output or not. See here, second condition case 2 also my S0 or 1 only. I feed back the previous values. What are the previous values? Q1. This Q1 will come here. So Q1 came here. And this Q0 will go to top. See, this Q0 went to top. Okay. Now both are zeros, so output is 1. Both are 1s, output is 0. So here we are getting Q1, Q bar 0. Previously what we got? Q1, Q bar 0. So this is the stable output. Now this output is the final output because this is the stable output. We have to take only stable output in the truth table. Okay. And I told out of 2 outputs, we consider only 1 because this is just a complemented version. Both are same only. Okay. And latch is a 1 bit storage element. We just need to store 1 bit. Okay. That's why I'm considering 1. This is called set condition. Set condition. So what we got, see, in the second condition, when I apply 0 and S0 or 1, I got Q1, Q bar 0. That's why set. I am considering Q set. That's why I highlighted. Okay. So we are storing 1 here. Okay. Now we'll see third condition. S1 or 0. Third condition we'll see. In this third condition also, we have to check with the different cases until getting stable output. So this is the condition 3, case 1. S equal to 1 or equal to 0. S equal to 1 or equal to 0. So this is 1 S1, this R 0. What about this 0, 1? Previous outputs. What are the previous output? Q1. That Q1 will come here. So here. And Q bar 0 will come here. Previous Q bar 0. Okay? Right. Now if any one 0, then output 1. If any one 0, output 1. Here both are same. So we should not consider this as invalid. We have to check if I feedback these 1, 1 again, whether output changing or not, that I have to check. But in case condition 1, why I have not feedbacked? Even we do feedback, we will get same. That's why, that is the reason. It means whatever I shown for the condition 1, that is the stable output, final output. Okay. So now we will see case 2 for condition 3. We will feedback these output values, but this input will remain as same, 1, 0 only, S1, S0, R0. Okay. So when I feedback previous case outputs, it will become like this. So both are 1s, output 0. Here at least 1 is 0, so output become 1. Okay. But we don't know whether this output will maintain stable or not. So that's why again we have to check case 3. Okay. So now case 3, again I will in case 3 also I will maintain same S1 or 0. I feedback previous case output. So now I am getting both are 1, so output 0. Both are zeros, output 1. So it is stable, because in case 2 what we got, Q0 Q bar 1. Here also we got Q0 Q bar 1. So this is the stable output. So we have to take it as a final output for condition 3, and we have to note down it in truth table. So for S1 R0, what is the output? Say for S1 R0, Q equal to 0, Q bar equal to 1. So we are storing 0. 0 means reset. I told we are taking only Q. Okay, I told the reason why we are not taking Q bar. Okay, but some other applications, based on the applications, we can take Q bar also. We can neglect Q. For example, in 555 IC timer, I observed there we use RS flip flop. There we take Q bar. So according to the application, we take any one. Okay, here I consider Q. Okay, then we'll see last condition. What is the last condition? 1 1. What is the output of this last condition? We'll see. This condition is the condition 4. Here also we have to take a stable output. For that we have to check different cases. So here the input values are 1 1, and I fed back previous case outputs. So this 1 0 will come here. So now both are 1s means output 0. Any 1 0 output 1. Okay. So now we'll check this output is stable or not. Again we'll feedback. When I feedback, I am getting same. So this is the stable output. I will note down this one. Okay. I will note down this one. We'll go to the truth table. So here 0 1. For 1 1, input 1 1, I got 0 1. Q0, Q bar 1. When I observe this one, this 0 1 we got previously also. For condition 3 also. So for condition 3 and for condition 4, we are getting same output. So condition 4 maintaining same output as condition 3. So in sequential circuit, if you are maintaining previous output or same output as previous, then we called hold. That's why this is called hold or latch or no change. There is no change, it is the same as previous. Okay. So here you may get confused between stable output and hold. Hold means when we compare different conditions, that is hold. Okay, stable means in the same condition. Suppose when I take condition 2, case 1, and condition 2, case 2 itself. In the same condition, when we comparing outputs, that is called stable. But when we compare in different condition, that is called hold. Okay, so this is the working of a NAND latch, SR non-gated NAND latch.